I'm here to present Marcus, an event-centric NLP pipeline that generates character arcs from narratives. I'm the first author, Sriharsh, Bhyravajjula. I would like to thank my co-authors, Ujjwal Narayan and Manish Srivastav. All of us are affiliated to the International Institute of Information Technology, Hyderabad. I'm presenting it for Text Story Workshop at ECIR 2022. This presentation will consist of 8 sections as visible on the screen: motivation, introduction, the pipeline itself, how we evaluated it, the applications of our pipeline, future work, the conclusion, and the references. Motivation. The motivation for our work stems from a lecture on the shapes of stories by the famous American author Kurt Vonnegut. He plotted the change in a character's fortune across a story and suggested that there are certain shapes to these journeys. We take inspiration from his idea and we build a pipeline that can generate similar character arcs. We use proxy markers of emotion and sentiment to determine relation-based shifts in a character's circumstance over a timeline measured by events. In introduction, we'd like to talk about a couple of key concepts. The first concept is the idea of circumstance. The circumstance of a character in narrative influences and changes their inner state. But the change of inner states also influences a character's circumstance. It's a mutual interaction. In this way, a character is both an actor and an experiencer. These mutual interactions are visible in narrative events where the character interacts with other characters in the narrative, leading to relation arcs between character pairs. Aggregated relation arcs give rise to unique character arcs. These character arcs are important theoretical devices employed in literary studies to understand character journeys, identify tropes across literary genres, and establish similarities of characters in narratives. This work brings tangibility to a theoretical concept by addressing the novel task of computationally generating event-centric, relation-based character arcs from narratives. In the next section, we will talk about the pipeline. Marcus, which stands for Modeling Arcs for Understanding Stories, is an NLP pipeline that plots a character's arc as their quantitative interaction with circumstance, as both actor and experiencer, represented by the proxy amalgamation of their event-centric relations across the narrative. There are multiple steps in the pipeline as shown on screen. We will elaborate on each in the slides that follow. The dataset. We use 2 primary data sources for our experiments. The first is the Harry Potter septology, which consists of just over 1 million words and 93,000 events. The second data source is the Lord of the Rings trilogy, which consists of almost 500,000 words and 28,000 events. For each source, before we feed it to the rest of the pipeline, we ensure that we remove page numbers, unnecessary annotations, unreadable characters, web links, etc. We feed the pre-processed data into a Book NLP module of the pipeline. Book NLP by itself is an NLP pipeline that scales to books and long documents in English and performs tasks like part of speech tagging, dependency parsing, named entity recognition, character name clustering, and pronominal coreference resolution. You can see the accuracy of the different parts of the Book NLP pipeline on your screen right now. We feed the features processed from the Book NLP module into a tagger consisting of a BiLSTM model with BERT embeddings to extract events and corresponding entities from the narrative. The tagger is trained using the lit events dataset, which provides an annotated list of events from over 100 public domain novels from Project Gutenberg. We process each event with a BERT-based semantic role labeler provided by Allen NLP to extract the latent predicate argument structure of the event and identify roles of participant characters. The next part of the pipeline deals with quantifying circumstance. This has two subtasks. The first one is sentiment extraction and the second is emotion extraction. We pose sentiment extraction as a regression task to capture the subtleties of relationships. We fine-tune a Robota model on the Stanford Sentiment Tree Bank dataset to obtain a fine-grained sentiment score for each event. For emotion extraction, we use a BERT model trained on the Go Emotions dataset in a multi-label setting, as interactions can have more than one emotional undertone. Marcus uses the confidence of the model's predicted labels as well as a manually assigned value for each label to contribute to the measure of circumstance. We empirically find weighted heuristics for combining these two measures to achieve a quantitative measure of circumstance for each event for each actor-experiencer pair. We employ smoothing with the Savitsky-Golay filter to retain information from past events in both relation and character arcs. On your screen, you currently have a sample output of the Marcus pipeline for Frodo Baggins, who is the protagonist of the Lord of the Rings trilogy. Now, there are two different arcs in this figure. One is in light blue, which corresponds to Frodo the actor, who proactively acts on his circumstance, and the second arc is in magenta, which is Frodo the experiencer, who is the subject of a circumstance. Now, for the most part, they seem to be moving together, rising together, falling together, but there are certain points in the arcs where we can see a stark contrast between the actor and the experiencer. This can explain instances where the character is trying to oppose the circumstances that they find themselves in. But before we get into that, the x-axis represents the events present in the Lord of the Rings trilogy. As mentioned, there were 28,000 of them. It is not necessary that Frodo was present or was an actor or experiencer in all of them. However, between events where Frodo has not been mentioned, smoothing fills in the gaps. The y-axis is circumstance. In the current image, it ranges from 0.4 to 1. However, we are not interested in the absolute value of circumstance or the absolute range of circumstance. We believe that that is a function of the novel itself or of the genre or of the character in question. What we are interested in primarily is the shift in circumstance. Where does the arc go up and where does the arc come down? There are certain points in this current figure that have been annotated for further elaboration. 5 of them, in fact. I'll go through each of them in detail. At point A, we have an extremely negative event for our protagonist Frodo when he is stabbed by the poisoned blade of the Nazgul at Weathertop and almost dies. This is a very negative event and it is been accurately captured by the dip in the experiencer arc of Frodo as well as the actor arc of Frodo, and it's a valley. In point B, Frodo reunites with loved ones at Rivendell, is nursed back to full health by the magic of the elves, and is experiencing an upturn of fortunes, and hence this is represented by a peak at point B. At point C, Frodo is in deep grief after one of his closest friends, the wizard Gandalf, falls to a monster, a Balrog, in the mines of Moria. This is again a very negative event and it leads to a drop in the experiencer arc of Frodo. However, it is interesting to note that the actor Frodo has a positive upturn, which indicates that he is trying to oppose his circumstance by keeping his spirits high and leading the group together out of the mines of Moria with Aragorn. We move on to around the 20,000 event mark, where at point D, Frodo is attacked by a spider Shelob in her lair. This is another negative event for Frodo, and this is accurately represented by a dip or a valley of the arc. Towards the end, at point E, we have another positive event, the conclusion of the story, where Frodo succeeds in his quest and returns home to the Shire and onwards to the sea. This is accurately represented by both arcs going up, representing a positive shift of circumstance or a peak. The next section of our presentation details the evaluation methods that we have used to evaluate our pipeline. There are two different approaches that we employ. The first is a survey, and the second is the use of gold label data. In the survey, we ask a set of 16 human volunteers, all of them avid fiction readers aged 20 to 31, to peruse both the Harry Potter and the Lord of the Rings series, following which they evaluate our system by answering surveys on two tasks, which are detailed in our paper. Based on the outputs of our pipeline, we achieved an accuracy of 71.5% on the first task and an accuracy of 72.9% on the second. In our second approach, we use gold label data, and we have a volunteer extremely familiar with the story annotate the first 300 events of the Lord of the Rings trilogy involving Frodo Baggins as a participant character. The annotator marks each event with 3 labels denoting a positive, neutral, or negative shift in circumstance, and we measure the alignment of labels to the pipeline. We discover that our pipeline performs well on negative shifts of circumstance and tends to assign positive labels to neutral events. The next section of our presentation deals with future work. We identify notable challenges in our approach to be addressed in future work. Since Marcus is a sequential pipeline, it is challenging to determine the effect of errors cascading through the system quantitatively. Another challenge was that our rolling window makes the arcs dependent on the availability of data. Event paucity in short stories or for low mention characters hinders arc generation. We observe that in our arcs, our fine-grained events do not represent an abstract view of the discourse. A more contextual representation of events is needed. Yet another challenge is that in our understanding of a character's circumstance, localized interactions with other event-specific characters heavily influence shifts. We need an effective means of capturing the latent relative importance of character-specific interactions. The last challenge that we observed was that our approach does not aim to handle nonlinear narratives where events are not sequentially presented. Apart from challenges, we also believe that investigative work can be carried out for multiple novels and participant characters with the existing system to understand tropes, arcs, and genre-specific shapes of stories. We believe there are many exciting applications to the Marcus pipeline. We list out a few of them in the slides that follow. Number 1, we believe that character arcs can be used in a more nuanced approach for detecting similarity between narratives, leading to a possible improvement in book recommendations and movie recommendations based on stories and scripts respectively. We also believe that character arcs can help with the digital enrichment in e-readers, adding to the rich metadata provided by devices like, say, the Kindle. We also think that character arcs can function as guidance for natural language generation tasks in the field of fiction. And lastly, we believe that character arcs can help narrative studies by quantitatively identifying character tropes and personality traits. The conclusion. We propose Marcus, modeling arcs for understanding stories, an NLP pipeline that addresses the novel task of generating character arcs from narratives. We explain our task, the axis of the plot, relation arcs, character arcs, and delve into the details of our event-centric approach, which leverages proxy markers like sentiment and emotion for circumstance. We then evaluate our pipeline on a particular dataset and present our results. We discuss challenges, elucidate future work, and outline potential applications. We also make our code publicly available for future use and replication of results. Well, that was our presentation. We hope you enjoyed our work. We hope that we did a good job of presenting it. If you have any questions, please feel free to reach out at the email ID mentioned on the screen. We would like to thank the organizers for inviting us to Stavanger, Norway, where I happen to take the wonderful picture that you see in the background. Thank you for your time.